Welcome, everybody. National Surface Finishing Day presentation by Bales Metal Surface Solutions. Today, your host, as you know, Rich O'Brien, has been with Bales for 26 years. He started out in polishing, has done some scheduling, customer service, and worked in our shipping department. Myself, I've been with Bales for 5 years. What I bring to Bales is 32 plus years of experience in manufacturing. Yeah, I've been on the bench as a CNC machinist, primarily mill and sinker. I've also done some mold making, and I've also dabbled in operations management for an injection molder, an insert molder, and then we also did some over molding with some LSR material. So I kind of understand a little bit people's pain points from start to finish, and that's kind of what we do here. We finish what other people start. And we pride ourselves in, producing a quality product and meeting the needs of our customers. So jumping right into it, I'm going to play a short little video. It's kind of give you a little tour. It's not so much virtual, but it's a little bit of a tour of, kind of what we do here. Not a lot of people, especially out of state, you have the opportunity to come and visit us, or with the COVID that's going on. So right now, we're going to just watch a little bit of a minute-and-a-half video, just kind of going into what Bales is all about.
I'm Stacy Bales, president of Bales Metal Surface Solutions. What began as a simple polishing company in 1978 by Steve and Mike Bales has grown into a premier coating and finishing operation. As second-generation owners since 2009, my sister Sarah and I are excited to continue our family's tradition of providing high-quality services to support U.S. manufacturers. We offer several trademark coatings like our Diamond Yen, Nibor, and Nickelon, as well as diamond chrome, hard chrome, diamond polishing, micro TIG welding, and passivation. Our dedicated team at Bales has the expertise to tackle complicated and critical projects, from big to small, from aerospace to medical to automotive. We've seen and protected it all. We are proud to finish what others start.
Okay, so we'll get into the presentation, the meat of it right now. Oops, my bad.
I'm Stacy Bales, president.
The solutions we offer, I apologize for that. I got a sticky finger on my laptop here. What we offer here are some solutions, whether it be polishing, plating, or a combination of both. Polishing, effective part release, or just design itself to achieve a certain finish. Plating to effectively aid in part release, corrosion resistance, abrasion resistance, or a combination of both. Some applications, especially materials that we run nowadays, you may actually need the plating to help protect your components. We'll jump in. Polishing, there's 4 types of polish finishes, from your A1, A2, A3, which is your diamond polish, your paper, which is your B1, B2, B3, your stone finish, your C1 through 3, and of course your dry blast, which is typically a glass bead media as a D1, or down to a D3, which could be an aluminum oxide blast. Here at Bales, at the blast end, we can meet any of your needs, with whether it be a hybrid mix or not. So, first off, diamond polishing. It takes time and skill to achieve this finish. This finish is very technical in nature, depending on where we're starting to get to this, to achieve that finish, whether it be just a straight mill finish or a ground finish, you still have steps in order to achieve it, utilizing the stones to get you where you need to go, and then finalizing with the different types of diamond compounds. This finish can be used alone with chrome or nickel or by itself. So, some folks don't actually like plating, but, with the materials that are out there today, protecting your substrate is important, protecting your finish is important, and then sometimes you may need a combination. It enhances in part release, with a nice quality finish, aid in part release is critical. What you see is, maybe you've got a part and you're ejecting, your direction of pull is either horizontal or vertical. You want to, even though it's a high polish finish, you still want to kind of polish that in the direction of draw, just to make that part come off even easier, or the certain finish you're looking for. But this is the most refined finish, and once again, it's on the A scale of the SPI scale. It's also this finish is actually great for, like, if you're running polycarbonate material or other types of materials similar to that. We could easily guide you in the direction of the finish you're looking for. However, we know out there, parts are designed by the end user, and you may not have a say in it. You may be stuck with a certain finish that may not lead towards the proper release that you're looking for. But however, we can achieve all of those any way we can. Next finish would be the B finish, paper finishes. You're basically using different types of grip of emery paper. It's the second most refined finish. This can give you a slightly reflective or glossy look. You got to be a little careful here, especially if your call out may be some sort of gloss level on a part that you're trying to hit. So you just got to make sure that those things are taken into consideration when you're choosing the finish, whether it be at Bales or even in your own shop or somewhere else. This also provides good release. It's not as good as your A finish, as your diamond finishes, but what can happen sometimes with a diamond finish, you may create a vacuum effect depending on how the part is designed. So it may actually stick more. So there's just some things you need to think about. And usually an expert at a plating or polishing shop can guide you in the right direction, and kind of finding what will work for you if your customer is not calling out a certain type of spec. So we could easily take care of that. Moving right along, the next refined finish is our stone finishes. Now you're in the C scale of the SPI. Me being a former mold maker, this is probably about as far as I can take a polishing. It's easily removing cutter marks, things like that. It provides adequate release. However, it's not, refined as your B's and your A's. It will give you, minimal gloss or shine. This is also good for, like, say your non-show section, your non-show part of your part, the backside or whatever, it's not visible. It's always good if you can get away with kind of, sneak in, maybe a little less effective type of finish on your backside of your part. It's a lot rougher, definitely. But however, with the certain stones that are out there, you can achieve a really nice finish, especially if you need something, you have a little part to stick in, you put a little draw polish stone on there. It definitely can help aid in releasing your parts. Also, when you say if you're doing some automation equipment and you have a channel or something, you just need to, make sure that everything's smooth, kind of get rid of all the imperfections that may have happened in machining or whatever it may be, or just kind of blend a transition area. A stone finish will definitely help aid, and say if you're running like a bushing through a feeder bowl into a rail that goes into a automation end of arm tooling, whatever it may be, it definitely can help you there. Once again, like I said, this is, non-aesthetic parts is really where you're looking for that stone finish. However, we've seen parts, and I'm sure other folks have seen parts where a stone finish is sufficient enough for the product that they're molding. If you're molding coat hangers, I'm sure you don't need a diamond finish. So something to think about. Now we're down to the D scale on the SPI scale, D1, D2, D3. You can pretty much, there's other blast medias out there. You can almost, come up with your own hybrid blend in order to give a various texture or a stipple or even like a look that you're looking for. Typically glass bead blast is number 11, and that's our D1 on the SPI. And then down to a D3 aluminum oxide. What's nice about the blast is to see if you have some machining imperfections, you can easily go in there and then just kind of give it a light blast and kind of hide some of those imperfections that maybe you need to run some samples and you don't have time, but you want it to look like a fairly decent part. You can easily put a blast finish on something and then just kind of, touch it up later or whatever it may be. But it's definitely, it's really a good tool to use for like camouflage and some, defects. And then the rougher the surface, the rougher the media blast, it will act as kind of a part, retainer, help keep that, on one side of your tool. You may have a sticking problem, it's sticking to the wrong side, that's a whole new problem. So instead of putting like undercuts and detents and kind of, scratching up your part or kind of disfiguring it, you may want to just kind of give it a little bit of a bead blast look. May aid in kind of helping you to shift that part from sticking from one side to another. Especially if you're running like an automated system and you've got end of arm tooling coming in there, the last thing you want is, for it to stick to the wrong side. However, we have coatings if it's, you need it to go the other way, whatever it may be. So we'll jump on. First section of questions. Any questions out there? And hopefully I didn't blast through that too fast. No questions? Everybody's good?
In the chat.
Everybody's using the chat?
No, I don't have anything in the chat just yet, so.
Okay. All right. Well, with that being said, now we'll get into the actual plating aspect. At Bales, we offer 6 types of coatings. There are other types of coatings out there. There are other coatings that may be, fit your needs a little bit better than what we offer here. And we'll also steer you in that direction. We're not afraid. There's plenty of coating companies out there. Everybody does their own little thing, especially if you got some sort of automation part and you need something with a different color, we may steer you to, one of our competitors, because everything we do here will mimic your steel surface. It may be a slight difference, but it's going to give you that silver look. So if you're trying to pick something up on a camera or something like that, you may need like a black chrome or even like a gold look with a tin coating. We're definitely going to guide you in those directions. We'd love for you to use our coatings. However, we understand. So jumping into the coatings, we offer 2 types of chrome, which we'll get into first, diamond chrome and hard chrome. And then 4 types of nickel, just straight Electrolus nickel, your nickel Teflon, your nickel boron nitride, and then your nickel diamond. And we'll jump into those types of coatings right now. Diamond chrome. Everybody's running material that's high glass filled, high fiber filled, 40, 50%. We even got a request, somebody had 55% fiber filled. 85 Rockwell, it's going to take the abuse. Let the coating take the abuse, protect your substrate. That's the key here. I mean, with all these weird materials that are out there, you need to protect your investment. Some of these components can cost thousands of dollars. And the last thing you want to do is have to kind of re-weld after you get a certain wear area. This way, if you identify your wear areas and notice them, and then you have a coating on there, whether it be Bales or anybody else's, you can easily strip and replate and then protect that substrate. I mean, that's the key right there. Going into it, diamond chromium matrix, it's co-deposited. Like I said, 85 Rockwell, it's ultra high dispersion of diamond, which is mixed into the bath. What's nice about the chrome, it's only applied at 130 degrees Fahrenheit. So if you have a component, we're definitely not going to distort any of your thin walls or your thin pins or any of those details. You may run into a question, well, how do you run these at? And, the chromes all run at 130 degrees F. Any of the coatings we have here, whether it be chrome or nickel, can easily be stripped. We can definitely take care of that for you. You know, like I said, these resins that are out there today, it's really important to protect your substrate. You know, I used to, when I was on the bench back in the day, I used to kind of think, you know, if a tool's built right, you definitely don't need plating. You know, if you build it with the right amount of draft and all the bells and whistles, you don't need that. That might have been the case years ago, but however, today, the more and more different materials that are fiber filled, glass filled, whatever it may be filled with, wood filled, you definitely need to protect yourself. And it's important, not only do you think about one of our coatings, but anybody's coatings, just to protect your tooling. What's nice about the diamond chrome, it's also good with release, a 0.15 coefficient of friction. It's definitely pretty slick. So it also aids in resin flow if you're running a part and you have some weird areas where it may be your mold flow test may have been showing you might be hard to get in here. Definitely with a coating on there and a slick surface will definitely aid in that resin flow. And also, you know, it may actually enhance your cycle time with the, you know, your injection speeds and things like that, getting it from point A to point B to totally fill out your part. Hard chrome, tried and true. Everybody knows hard chrome. Good abrasion resistance at a 72 Rockwell. It's nice. It's great. What we like to use it for, flash chrome, you know, to protect your substrates. And also say, your tool guy happened to have an oopsie, and now you kind of machined a detail a little bit too deep, and now you need to kind of, instead of putting a shim in a behind a cavity or a core detail, you can build up that back, say with 5 or 10 thousandths per side just on there. You'll have to do some remachining to get it even, depending on the size of the part, but it's definitely something. Being on the bench, I have times where I've been at places where they had shims, a bunch of shims, and it's like, why not plate these? Why not weld these? So these shims, they fall out, they stick to grease and those type of things. You do a little buildup on the backside, and now you don't have to worry about that. You can assemble your tool, you're race ready. Now you don't have to, oops, I forgot that shim, and now we shot the part, and now we have a step around a pin area, whatever it may be. This provides excellent release and wear characteristics. One thing to note, PVC material, chrome and diamond chrome don't like each other. So it's important that you, when communicating with any plate or here with us at Bales, the type of material you're running. A lot of times what happens if it's, we may forget, the customer doesn't even think about it. And now all of a sudden we plate this $2,000 plating job, and then you say, hey, the plating failed, and then we ask, well, what kind of material you're running? It's important that you let any plater or any shop you deal with know the material you're running, if you know it offhand. I know what happens a lot of times, you may design the part and you're going to run nylon, and then the customer changes their mind and now they're running PVC. That happens, we get that. But however, it's always important, the more information you can give any plating organization, is great up front to help, minimize the reworks and, the bad taste in your mouth and those type of things. We want everything correctly from start to finish. So as you know, with chrome, we have to build a conforming anode. As you see in the picture, the anodes, we want to direct the chrome onto the part surface. You could see in the two where it just looks like a big jumble mess. That's actually every little individual wire built so that we can get complete coverage on a block that's, say, 36 by 30. It has that much detail. Or you can go to the picture in the middle with a simple ring. They want to build up on that diameter. They machined it wrong. It's a simple ring. But however, you need to build an anode for chrome. And what typically happens with chrome, the more you put on, the more of the likeliness of you have an edge buildups or those little like pimple balls or whatever it may be. So it's important that you spec out your dimensions properly, give us the right material, and we can move on our way. And then of course the picture to the left, to my left exactly, is just a simple anode that may have taken maybe an hour, but the cost driver in really in chrome plating is building the anodes. I mean, as you see, the one with the, I think that was a 40-hour job. So, you know, you can just imagine what it takes to do that. So moving out of chrome into nickel, here we go. Electrolus Nickel. Excellent for corrosion protection. Better than chrome, especially if you request high phos plating. High phos is the way to go for corrosion protection. Same with oxidation. Gives you a little bit of abrasion resistance. Typically applied Electrolus Nickel, you're sitting somewhere right around a 50 Rockwell. What's nice of any of our nickel products, which we'll go into the other three here shortly, it flows evenly everywhere. So you can almost guarantee the size of the part, you're going to be within 50 millionths or even a tenth from top to bottom, deep walls, wherever it may be. What's nice also about nickel is you don't need an anode. We can simply rack it and run it through our tank process. It's a little more detailed than that, but it's that simple. We just don't dip it and hold it in our hand, but we do build racks and, you know, run these things through. It flows evenly everywhere. That's the key. I mean, especially those hard to reach areas, deep walls, deep pockets, deep ribs, things like that. Nickel Teflon, excellent corrosion protection, you know, pretty much the same as Electrolus Nickel. What's nice about the Nickel-On, it's great for your LSR and rubber molds. Back when I was in a previous life, I actually worked at a place where we actually sent our liquid silicone tools here to Bales to have our gasket trails coated with nickel Teflon. And it was a lifesaver. So it's just something to think about. It's also good release. It's been around for a while. It's one of those hybrid coating that's been around for a while. However, you know, it really stands out, especially your LSR and rubber materials. Once again, evenly deposited. It is a release coating, so it definitely will help on those parts that are difficult to eject, or the part that's you know, built with no draft, you know, because that happens. And it extends mold life. Any of the coatings, any of our coatings, any of anybody's coatings will definitely protect that substrate, and that's the key here. I mean, you guys spend thousands of dollars on tooling, whether it be molds, dies, automation equipment, end-of-arm tooling, grippers, whatever it may be, pins. You know, it all costs money to, one, you know, the raw material, two, the shop time, and then the time that it's, you know, your assembly, and then the time you run it. So it's important that you build a quality tool and make it last. And we have some solutions, and so do other platers, to help protect that. Electrolus Nickel boron nitride, our NIBOR. Which is nice about this is now we can add a post-bake option to it. NIBOR, as applied, sits around a 54 Rockwell, which isn't too bad. It's typical of most steels that are heat treated. Also, if you post-bake it at 550 for 3 hours, now you've achieved a 67 Rockwell. As you saw in the earlier slide, the hard chrome is a 72 Rockwell. So now you've got some, you know, excellent lubricity at a hardness that's near the hard chrome that, you know, here without building an anode, it's going to flow evenly everywhere. That deep rib, that pocket, it's going to go in there. It's going to cover it. Where with the chrome products, you may run into the fact of you don't quite get the full coverage in a corner. And everybody knows that the one spot that you don't get the plating is going to wear first. It's just going to happen. It's the nature of the beast. You know, we try to, you know, simple jobs in chrome can easily be covered. However, the nickels flow evenly everywhere. And in our next slide, it'll even be more beneficial to think about if you're doing something with a chrome and you have some, you know, details that are a little tricky to get to. Once again, easily stripped. Any of our coatings, we can easily strip. This is an alkaline strip. It's, you know, one, it may be time to do your PM and we could strip and replate it. Or you guys still to do a PM, you got a little bit of damage. You may want to just kind of, you know, grind or machine or even stone a certain area, maybe weld where you may have got a ding or something, and then send it to us and we can strip and replate all at once. Depends on logistics. It's kind of your call. It's just something to think about. You know, I know nowadays everybody needs everything yesterday. So, and typically a plater or polishers, we're last in line. So we understand the urgency. However, it seems like everybody's got an urgency these days. So, it's just something to think about. With it being that 0.05 coefficient of friction, it is very slick. It's the slickest we have. Most of our business, we do mold components that are looking for release is NIBOR and nitride. What's nice about it too, it can withstand 1250 degrees F. So you're running a mold and all of a sudden your cal rod heater ran a little rampant. You're definitely gonna probably still have those properties intact. Now, if you had the nickel Teflon, that can only handle like 550. So if you get something that goes a little out of whack, you run the risk of typically destroying that, those Teflon properties of that coating. So it's something to think about. However, with NIBOR, it's great for most of the, the resins that are out there. Some of the higher the durometer rubber materials definitely withstand the NIBOR. But some of those LSRs, the sticky material, can be a problem. What also could be a problem too is you got a high polished surface and you want to add for more release, you may create a vacuum. And there are some tricks that we can discuss in regards to, taking care of those things, to aid in your part release. Once again, this is the slickest we have. And it's definitely got a part that stick. This is the way to go. Or even, not to, jump backwards a little, but even if you, once again, you're looking at that cycle time, resin flow, that's important. Everybody needs to make parts faster. These are the things that, production, 2 or 3 seconds through a 24-hour period or a week's time, most people, that are in the industry or any type of production setting, seconds means everything, downtime means everything. So if you can protect your substrate, increase your cycle time, it's a win-win. Identify the areas that you may run into problems and fix them beforehand. It's definitely something to think about in keeping your back pocket. Diamond EN, as applied, 57 Rockwell. So here we're almost, at a nice hardness just as applied. However, that post-bake option, 70 Rockwell. Now you're right there with the chrome. It's definitely the way to go, especially if you got something, those deep ribs, those pockets, the thin walls, those type of things, hard to reach areas. What's nice about it too is now if you have a large block that has a lot of detail, example is that anode that we showed earlier with all that wire bent. Now you don't have to, wait the time to have the anode made, especially like we said, timing is everything. Typical lead times, are about a week for our Diamond EN, and then chrome can be upwards of 2 weeks or more, depending on the anode construction. And, timing is everything. And if you can get away with the Diamond EN material, it's just definitely something to think about. Easily stripped, like always. Low coefficient of friction, 0.1. It's pretty slick, not as slick as our NIBOR. However, it is excellent for release. Withstands up to 1000 F. So once again, you get that rogue heater rod or something that goes a little astray. It's definitely going to hopefully withstand that. You also got to remember too, these are only surface coatings, so they're only applied on the surface. Your rogue setup tech with a screwdriver instead of a brass pick trying to pick out a part, if he hits it hard enough, you could damage the surface. Ideally, that never happens. But it's just one of those things you have to remember and just kind of, this is only on the surface. Once again, it's an Electrolus process. It saves you time and money. This is the toughest nickel product we have here. Also, typically the nickel products, we like to stay around the, half a thousandths deposit. We can go a little bit more, a little bit less. However, we like to stay in that range. Ideally, we would love to just put 2 to 3 tenths per side on everything. However, sometimes you've got a tight fit area and now, hey, Rich, I only need 50 millionths. That's all I can afford. So yeah, your longevity and your life of your coatings may be compromised a little bit, However, we definitely can take care of that too. And it's just something, also to think about. When it comes to buildups, we try to stay away from that with nickel. However, with just straight Electrolus nickel, bouncing back a little bit, you can put up, thousands or two. Now you just run the risk of some micro pitting because of the way it's in the tank and things like that. However, if you, try to spec it out and let us know what your needs, what your fits are, and those type of things, we could steer you towards the right direction. Aluminum and beryllium copper. Soft substrates. Everybody uses them right now. I mean, aluminum is easy to machine. Those aluminum shops that are out there, the prototype shops, they can guarantee you a tool in 2 weeks, whatever it may be. What's nice about that is you can take an aluminum tool, put one of our harder nickel coatings on there, say, Nibor or Diamond EN, and now you've extended the life of that prototype. Your customers, okay, I need 30,000 shots, and you still got 8 weeks before the tool's built, or whatever it may be. I'm just throwing out numbers. Extend the life of the prototype tool. Also, it's been known that folks are building aluminum tools and just coating them to extend the life that way, or convert that prototype tool into production. Now all of a sudden, you've built the tool and budget constraints happen, and now they put a kind of a stop on it, and now you can run that aluminum tool, put a coating on there, and definitely make it last. We have a couple customers that have over 7 million shots on an aluminum tool that's been Nibor coated. What's nice about this too is, as you see in this cord here, we just kind of coated the wear area at the top. Also, the one main reason you use copper is for cooling properties, and you're only putting a couple tenths on there. Even if you coated the whole thing, you're definitely going to not affect those cooling properties that you need to aid in your part release that way too. Also, you put a coating on a beryllium copper tool, you may, protect from corrosion protection. Just a little bit of things to think about with nowadays, these production tools that are made out of the softer substrates. Protect that investment. Realistically, it is the key here. I can't say it enough. I mean, because I've been on the bench, I feel your pain. I've dealt with some crazy setup techs, rogue, operators and those type of things, and it's a nightmare. And if you can protect it one way, a coating not only from Bales but from anybody would be the way to go. Not just for molds, as you see here, it's kind of a funky picture. However, you see the corrosion that occurred. This is one of our customers that this tool was actually only in service for about less than 6 months, and the water just kind of destroyed it. So we actually put an Electrolus Nickel coating on there, cleaned it as good as we could, protected it until they were able to actually build some new cores. And then what we did is we actually then coated Electrolus Nickel on those water channels. Not only can you use it on water channels, but your water lines. If they're large enough, we can, submerge the entire tank, the entire part into the tank. It's definitely, beneficial to coat those. Not everybody runs, the best, cooling system in their tools. Everybody says, oh, the glycol is where it needs to be and those type of things. However, sometimes those things get overlooked, and then you go to do, your PM or whatever, or you start to see a water leak, and now you've got a new nightmare. We do stripper rings, automation parts, end of arm tooling. What's nice about the end of arm tooling, typically on a robot, you want it light, so you're building stuff out of aluminum, especially the grippers, things like that. You're pulling parts off. Some folks use vacuum, but I know of some folks that actually use grippers. Put those with a Nibor coating. Now you help protect that substrate. Get a little more life out of it. Where in a past life, we actually we machined our own end of arm tooling grippers, and we actually coated them to extend the life of them. Instead of buying them off the shelf or whatever it may be, just protect it. Stop from gassing, help protect from gassing. Typically most of these weird materials that are out there, you'll start to see the gassing build up, especially in your vent areas. what happens to a bare substrate is it starts to attack the steel. And now put a coating on that, protect that substrate. And now the gassing's not going to stop. However, it's going to be easier to clean, especially if you use one of our lubricity coatings. Now you can easily wipe that off. And then you can easily, part of your PM schedule is, take a little drop of copper sulfate, say at your end of fill, your gate area, your vent areas, which typically wear first. And then just see if you got some wear. Stop it before you have to start welding tools and then welding and re-welding and cutting and all that good stuff. Back and forth. And if you keep welding something, it's not going to hold up over time. Then you're going to have to, have a reinvestment to either insert or whatever it may be. And now you extended the cost. Protect that substrate. I can't say it enough. So you don't want the coating in a certain area. So we can easily, keep it out of holes, especially knockout pins. We can easily put some neoprene plugs in there. Or you have that cavity block and the retainer block is, it's tight. And you can only, get maybe a tenth or two in there. Masking, we can do chrome. We'd use a tape. It's typically a 3M type tape. There's several different types of tape depending on the location of where the plating is going to be, and then further down on the part or whatever it may be. As you see in the picture here, this is our maskant that we utilize for nickel. It's a brushed on process. So if you've got a certain detail, say this little runner area was the only area we were plating into that gate drop, it's hard to see the little hole there, was the only area the customer wanted plated. They wanted the rest of the block masked. However, you got to remember it's a brushed on process. So now it's usually 2 layers. And just imagine somebody with a paintbrush, it's going to take some labor. It's going to increase the cost. So ideally, if you can plate the entire component, say that 2 to 3 tenths per side is the way to go. Now you've got protection everywhere. But however, we understand, inserts, fit areas, pockets, things like that. You don't want them to flash. You don't want any issues. You don't want any slop, whatever it may be. Definitely something to think about. Here at Bales, we have a high-tech lab. We have an in-house chemist who monitors our processes daily. Our operation manager works hand in hand with our group in regards to making sure that everything's on the up and up. We do testing for the different chemicals, making sure that our strip chemicals, our nickel chemicals, our soak chemicals, our strike, everything is where it needs to be so we can enhance the plating process so there's no issues. And in the top right corner is our x-ray machine. Typically what happens with all of our jobs, we run a little say 1-inch dull razor coupon. This way then the chrome plater or nickel plater can actually take that off of the line and then just verify the thickness that's being plated, the rate they're plating, so that we can target your desired thickness. If it's a small enough component, we can also put it underneath there ourselves. We do have, depending on, as long as we know the proper substrate, a lot of folks don't know, they just say it's carbon steel. But if say, hey, Rich, it's H13, we can plug in H13, put it under there, x-ray it, and now you see, okay, we've got 2 tenths or 2 tenths and 2.5 tenths, whatever it may be. But it's just definitely we can do, and like I said, a smaller part can fit in that footprint. It's kind of a small area. However, every job, even if it's a larger job, say it's a 30 by 30 plate, it's going to run with those coupons. And then what happens at the end of the job, when the job is done plated, the coupon, the final coupon that was with the job, stays with what we call the traveler, the job paperwork, so that we can ensure that down the line you call up and say, hey, Bales, how much did you put on here? I think it's too much or it's not enough, whatever. We have documentation that way too. Well, we are at the end here. Is there any questions or comments or concerns?
Hey, Rich, Patrick had a question about what type of steels produce the best diamond finishes.
Well, typically your tool steels, but you know, there are some you got to be careful of. Your H13 and P20s, you know, depending on the grades. You'll want to look at that. I do have a cheat sheet that I can actually, if you get his information, I can send it to him.
Okay. Yep, I have it.
Perfect. Any other questions, comments?
You can
I hope
feel
I didn't
free to
bore
turn your
you.
mics on.
Oh, that helps. We just wanted to take today, kind of give it out there for National Surface Finishing Day, kind of give you an overview of kind of what we do at Bales, kind of what, you know, a nickel process entails, or chrome process, or even, you know, the polishing. If interested, we can also kind of dive deeper and do a, you know, a specific presentation. You know, maybe not, I know this kind of I speak kind of more geared towards the mold making end, because, you know, that's where my expertise is. However, I mean, if you have some automation equipment, or you're just running general parts that need corrosion protection, you know, and if you're, you know, we could easily gear a presentation for your group or yourself or whatever, towards that type of industry, or whatever it may be. I mean, we do, you know, machine rotors. I mean, we do a lot of different things here. However, we just kind of focused in on this here today, but we can branch out and, you know, make it a little more specific to your, you know, your needs if needed.
We'll send everybody a copy of this presentation too, for you to review.
Well, Rich, what do you think? Are we good?
Yeah, I think we're going to wrap it up. Everybody's saying thank you. It was a good job, Rich.
Oh, thank you. Thank you for being on the front end. I appreciate it. I hope I didn't bore everybody, and if I did, I'm sorry. But like I said, if you need anything, feel free to reach out to Rich over at Bales. Just ask for Rich, you'll get one of us. And we'll help you steer you in the right direction, whether it's Bales Coating or somebody else's.
Yep, on behalf of the Bales team, we thank you for attending. And like Rich said, reach out to one of us if you have any questions. We'll be sending you an email with a link to the video and our contact information as well.